If you use Houdini every single day, you know there are nodes you just can't live without. And if you're someone starting to learn Houdini, you know there's a bunch of nodes yet to be learned. And these on screen are my daily drivers. And in this video, I'll do my best to walk you through each and every node, explain how it works, why, and when you might want to use it, along with a quick demo and explanation in context. On this channel, I'll learn and teach destruction effects in Houdini and Unreal Engine 5. And if that's of interest to you, liking, commenting, and subscribing goes a long way. So with that preface, let's jump right into the geometry node number 1. I'm going to select the container, tap I on my keyboard, and jump right in. And I'm going to press space H on my keyboard to recenter the view in the scene graph there. And let's do some housekeeping first. The way I'm going to explain this is, first I'm going to, actually let me zoom in. The way I'm going to explain this, I'm going to drop down the node I'm going to explain. Then I'm going to explain what the node does. Right after, when and why you might want to use it. And then I have put together a quick demonstration or a sample in context how you might want to use it, or at least how I use it. So the first node we talk about today is this test geometry Tommy. And if I press R on my keyboard, select the node, and put my display flag on it to isolate it, we can see this node in our live view there. And what this node does is it creates a soldier which can then be used as a test geometry. That's what it does basically. Now the question is when and why you might want to use it. Well, you use the Tommy geometry node as a human scale reference to quickly check proportions, spacing, and relative size when building environments, effects, or simulations. Great. We know what the node does, when, and why we might want to use it. Now let's look at this node in a real-world example. And I'll try to explain my thinking whenever I want to use this node. So to create this example demonstration, I created a simple box node, which creates just a three-dimensional geometry that you can proportion however you want. And actually, let me put a display flag on the end result first. So I tried to sort of create this a doorway to explain this node. Basically how Tommy can be used to gauge our proportions of the environments we create. And this is a good example how Tommy can be used. You know, we have this door frame, Tommy at the middle, and we can see that the scaling is on the right track. So to create this, I used the little box, and then I used the match size node to create the geometry flash to the ground. Then I used the Boolean operation that cut into this geometry. Then use the merge node to merge both together, and voila, we have this. And the fact is, I've heard that Tommy geometry is in proportions very similar to Unreal Engine 5 as well. So if you create anything in if you create anything in Houdini, it's a good practice to use Houdini to gauge your proportions and sizes of your environments, because the last thing you want to do is work in proportions that are way out of control, you know, and then import everything inside of any other application you want and be like, well, what is this? And why aren't my effects working? Because another thing I've heard is that Houdini solvers work best when your geometry is proportional closely to real world scales. And that's when Tommy comes in. I think actually one thing we haven't discussed yet is if I put my display flag to Tommy and press P on my keyboard and open up the node menu or the settings for the node, We see that there are a couple settings that we can change on this node. We can do translations in X, Y, and Z. So if you look at the screen here, we have this little vector in Y-axis, Z-axis, and red, which is X-axis. And this is basically what translate is. The first input is X-axis, which is red, which goes to the right of the Tommy here. And actually, I have this little cool dandy tool. Actually, okay. So actually, let me. Okay, so the X-axis is on the right. So if we check this translate bar at the top, the first is the X, then we have Y, and then we have Z, which goes towards us. And the middle one is a Y that shoots upwards. So these are a couple things that we can change. And if we try these settings, the first one is X, then Y, which goes up, and Z that goes either towards us or away from us. And if I click Control and middle mouse on this property, we can cancel it out to the default values. And the same goes for rotation. We all know what rotation is. We can rotate Tommy. Let's put in some concrete numbers like 45. And voila, we have Tommy at 45 degrees leaning towards us. I'm going to click Control and middle click to put it in default state. Then we have a scale if you want, for whatever reason, blow it up like that. I think default scale is much more better to work with. And then we have a little drop down for resolution, whether we want to work with the lower resolution geometry or we prefer to have it in high res. And of course we have clothing and textures and things like that that we can toggle on and off. Self-explanatory, simple node that you can use. All right, I think it's time to go and look at the node number 2, which is copy to points geometry node. I'm going to put my display flag to this node, and then let's look at what this node does. And in short, copy to points geometry node copies geometry in the first input onto the points of the second input. And let's look at what that means. We have our node, copy to points node. Here it is. And there are these two input pins. Okay, the first input pin here and second one right there. And if we hover over it, there's a little dialog box that pops up that says required geometry to copy. And on the second one says target points to copy to. So we know that we need a target geometry and points for it. And we're going to look at this in a second, what it means. But first, let's look at why and when we want to use this node. You use copy to points node whenever you want to duplicate geometry onto a set of points, like scattering objects across a surface, grid, or particle system. Let's look at what this means in practice. I'm going to put a display flag on the end result so you can see the effect of this node in real time as I try to explain what I did there. And we're using the same geometry of Tommy that I used in the previous example. And at the moment, I have put it in this weird angle. And where it is, actually I can't find where I changed it. Oh, I think I changed it globally. But anyways, I have the same geometry we just talked about. Then I created a simple grid node to have the points. Okay, if I press W on my keyboard, toggle on points, and these points as well, we can see that the grid consists of multiple points. And if we want to be very accurate and specific about how many points we have, we can go to the geometry sheet and click on this little empty space, okay? And when we do so, the points reorganize, and we can definitely tell that there's 62 points on the geometry. So when we perform this copy to points operation, we know that we're going to copy 62 examples of the Tommy geometry on the points. Again, so we have Tommy. Actually, let me get rid of those display flags or markers. We have Tommy. We have grid of 62 points. We understood that. And copy to points node is going to take Tommy and copy it onto these points. And that's what this node basically does. It allows you to scatter geometry onto the points. Very simple, self-explanatory. And if I press P on my keyboard and open up settings for this node, there's a bunch of things you can do with this node. You can pack an instance everything. You can basically do all kinds of crazy stuff. But it is outside of the realm of what we're doing in this lesson. I want this to be very quick and like simple way of looking at these nodes. And for an in-depth look at each of every node, we need a dedicated video on each node. Okay, I'm gonna press P on the keyboard to get rid of the settings, and let's look at the node number 3. I'm gonna put my display flag on the node, and here we have the third node that I use pretty much on daily basis is the match size node, and we looked at this. We had a sneak peek on this node just a moment ago. So I'm gonna put display flag on this node, and let's look at what this node does. And match size node resizes and recenters the input geometry to match a reference bounding box. Well, when do we use it and why? Well, you use match size node when you need to align center or fit geometry to a specific position, size, or reference object in your scene. And I have 2 examples to demonstrate this. To start with, let's look at the end result of this example. A very simple scenario. I want my box, just a basic cube, the most basic thing you can create in any 3D application, and Houdini especially. We create a simple cube, okay? If I get rid of the grid there, we can see it's somewhere in the space, okay? We really can't tell where it is if we don't have the grid, but once we have the grid, we can see that it's in the middle points, okay? It's not flush with the ground. So how do we solve this problem? How can we get our cube to sit flush to the ground? Well, and this is where the match size node comes in. What you can do, and if I press P on my keyboard, we can justify the minimal position. If I go to the justify Y, put it to the minimal, and then to the same, we can make it flush to the ground. And let me check what's happening. Some error happened here. Okay, hang on. Okay, we're good now. Actually, yep, I had an error in this highlighter software. We can make our cube flush to the ground. Well, let's look at the example number 2. Okay, what if we want to take that same cube and put a sphere on top of it? And we want to say, you know what? I don't want this to be offset a little bit. I want this to be flush. I want there to be no spacing at all. Especially if I take my box, go to the size Y, we learned that we have the X, Y, and Z. And if I adjust my Y position of the cube, you see how the sphere continues to be always on top no matter what we do? And this is proceduralism in Houdini in real time. No matter how we change this value, the sphere is always going to stay on top no matter what. And the way I create this example is, again, I started with a simple box that is being added into the scene at the center. Then I used match size node, and then I created the emerge node to basically merge the sphere with both elements. Very simple. And that's what match size node is, basically. And if you want to dive deeper into this node, You can, you can do all kinds of crazy stuff, and you can experiment on your free time. And this node might need its own dedicated video as well. Okay, node number 3. Node number 4, where we left off, is merge geometry node. And when I put my display flag on the node itself, you're not going to see any result in the scene whatsoever, because this is not a geometry that we're creating. What geometry node is, it merges together geometry from its inputs into a single stream of geometry, which you can then send through other nodes. Okay, now we know what it does. Question is when and when to use it, right? And we use a merge node when we have finished all parts of our effects or upstream work and want to combine them together into a single output. So that's the theory behind the merge node. Let's look at how it works in practice. And I showed you a couple examples before how I use merge node, right? It's very simple. I take a simple box, simple sphere, we put these nodes side by side, and then we use merge node to connect them basically. And if I press Y on my keyboard, I can cut through these wires and disconnect. And we can see on its own, we don't have any effect of the merge node. It needs and relies on 2 inputs. So, for example, if I take the output pin of a box node, plug it into the merge node, okay, we can see the result of displaying the box itself. If we take the sphere node and put the display flag on its own, it sits by itself, and once we plug it in to the merge node with the box already in it and put our display flag to it, now we have both nodes. Very simple, and that's what merge node is all about. It combines geometry into a single stream so we can view it together. Next node, which is the fifth node, is a transform node. Again, if I put my display flag to it, you're not going to see any effect whatsoever because, well, it is not a 3D geometry by itself. Let's look at what a geometry node does. Well, it transform node modifies the position, orientation, and size of the geometry in the scene. When and why to use it? You use transform node whenever you need to reposition, rotate, or scale geometry. Sounds very basic, right? It's like basics of 3D. We have our box that we have used multiple times now. We drop down a transform node, which by the way you can access by tapping tab on your keyboard and typing in transform. Okay, transform, and you will see it listed into the node menu. You can click on it, let go, and you have your transform node. Another way how you can look up you don't have to spell out the whole name of the transform node. You could say form, and interesting why it doesn't find. Let's say TRNS. Okay, now we can find it. You don't have to spell transform all by itself like a single word. You can type in TR and it's gonna find the transform node as well. So that's how the search works there. So if I put my display flag to the transform node, press P on my keyboard to bring up the node information, not node information, but the settings, we can see that we can do multiple things. And this is basically all about how we can transform the geometry in 3D space. We have these vectors Y, X, and Z, and with the translate, we can do just that. We can transform our object in 3D space however we want. We want to put it up, we can do that. We want to translate it in the Z direction, we can do that. And we can do the same for rotations, like rotate it 90 degrees there, 45 degrees here, 20 degrees. Like you see where I'm going with this? That's what you can do with the transform node. You can transform your geometry in multiple different ways along with scaling, up and down, and shearing. It's kind of like, I don't know why would you want to shear it like that, but perhaps you have like a very unique effect where you might want to use that. So very simple, that's what transform node is all about. Next node is the node number 6, and that is a null. If I put my display flag, nothing's going to happen, and that's okay because this node is very unique. So let's get to it. So what does null does? Well, the null node is a simple empty SOP, which stands for surface operators, that doesn't modify geometry but acts as a placeholder or marker in your network. It provides a reference point, organizes the network, and can serve as an output target. When and why you might want to use it? Well, you use the null node at the end of your network or subnetwork to mark the final output. And you'll see this all the time, artists doing this. They'll create their network. Okay, the same example we just looked. We merge sphere with a cube. And when we say, look, I think I have finished my upstream work, I want to mark it with the null. So you drop down the null. And what you'll see artists do, they'll say out something like box. And they usually do it with capitals. And you can use this to mark the end of your network. And sometimes you can drag this drag this node into other settings inside of the Houdini and different parameters. So that's what the null is all about. It's basically an endpoint of your network that really helps to read when you have finished your work. All right, so that's what null is all about. Let's look at the node number 7, which is an exploded view node. Pretty cool name. So what it does, exploded view node pushes geometry out from the center to create an exploded view. And when do we use it and why? You use the exploded view node to visually separate connected pieces of geometry, allowing you to inspect and understand complex models more easily. And this node especially is useful after fracturing. So let's look at how it works. So I have created this very cool test geometry template head. If we press tab on our keyboard, search for test, and we have different kinds of test geometries we can choose from. And test geometry template head is which I chose for this demonstration. And then I use a material fracture node we're not going to cover this right now, but what this node does is it fractures geometry into multiple pieces. If we zoom in a little bit, you can see that this head is being shattered into multiple lines. And this is where, it's very hard to showcase this without exploded view node, and that's why it comes in so handy. I'm going to put the display flag on the exploded view node. I'll give it a second to think through to give me the end result. Let's see. Oh, okay. And I'm going to press P on my keyboard to open up the settings for this node. And we can see that we can explode the mesh apart from each piece apart with the uniform scale slider. And it's a very cool way to view your geometry when you fracture. For example, if you fracture geometry for the RBD sims, or if you're working some effect that involves kind of shattering or breaking or exploding or things like that, you can use exploded view to kind of see if there are any problems in the geometry. Has the fracturing been good enough? Do you like it? Or things kind of troubleshoot any errors that you might have. For example, here is kind of weird spot. And that's what exploded view node does. It pushes geometry out from the center to create an exploded view. Okay, let's look at node number 8. I'm going to jump right in, which is a convert node. Display flag on it, nothing happens. So what is convert node? Well, convert geometry node converts one geometry type to another. And you use the convert node to change the geometry from one type to another, such as polygons, NURBS, Bezier curves, or volumes. And this allows you to make geometry compatible with specific operations, modeling workflows, or simulations. And this node is especially useful for preparing geometry, for downstream processing, rendering, or simulation tasks. I think you need an example to really wrap your head around it. Let's look at the end result first. So here we have the convert node in action. It's going to make sense in a second. So let me step back and start from the top. What I did is I drawed a simple curve. Okay, see, I can do all kinds of different things with this node, and to give you a demonstration of the convert node, I used the draw curve to make this random circle. But you see there's a problem. It can't for itself and end it by itself. So next node I used is ends. And that ended, basically put together these 2 points. Then I used the resample node, which if we look, we're looking at the points, it resamples basically our geometry to kind of evens out the points a little bit. And I think we can better visualize this with this slider. See how we can resample the points and kind of smooth it out a little bit. So that's what resample now does. And there's another problem we have. The normals are facing the wrong direction. If I see the bottom, normals are facing downward, and upwards there is no normals. So we use a reverse node to fix that, and then we use convert node, well, to say I want to convert this to something else. For example, polygons or mesh. And see how it kind of divides this into multiple uneven, I would say, quads. We can do Bezier curves, NURB surface, circles, you know, it's got all kinds of different things that you can do with this one. Okay, so that is the convert node. You can convert your geometry from one type of geometry into NURBs, Bezier curves, volumes, what have you. Okay, next one is the 9th node that I want to walk you through. And I'm going to put my display flag to it. And I'm going to make sure that, let's see. Let's troubleshoot. Okay, so I'm going to put my display flag on this node. By itself, you're not going to see anything. So what does this node do? Well, it creates points or polygons or adds points polys to an input. See, there's an input at the top that says source. So we need a source for this work, for this node to work. And when and why do we use it? Well, you use the add sup, which is surface operator in Houdini, to create points or primitives from scratch, or to reduce existing geometry to just points. An example, I have this test geometry rubber toy in my scene, and then what I do is I add this, the add node. And then if I put my display to it, open up the settings for this node, we can see that we can do multiple things with this node. See, there's a little setting that says delete geometry but keep the points. At the moment it's toggled on, and what it returns us is this, points, see? Let me uncheck this, and we're back to where we were, test geometry, right? Put display flag on test geometry, put display flag on node, add node, nothing happens. Why? Well, we haven't really done much. Well, if we don't look at this for a second, I'll explain this in a second. So we can do delete geometry but keep the points. So, and this is really cool to also like troubleshoot your geometry, see if everything's correctly or everything is how you want it to be, or maybe you just want just the points, you know. Another thing you can do is you can create multiple new points using this node. For example, if I put the check mark on this, 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 and this, you can see that I have created 4 different points on the grid. So we have point number 1. Actually, I'm going to put, we have point here, point there, point here, and there's a point below the test geometry. And if I actually delete each of these points, and actually, let me step back a bit. I'm going to bypass the test geometry node by tapping Q on my keyboard and selecting the test geometry node, and it's going to basically bypass it for a second so I can better showcase this node. So you can see what I have created here with this add node. You can add a point in 3D space by specifying whereabouts you want it to be. You can put it in somewhere in X position, Y position, which is up and down, and Z direction, which is forwards and backwards. And if I want, I can click on this little plus arrow or plus icon, and it's going to create this entry right here. And I can specify, okay, I want another point, and then another one, and then another one. And that's how you can create multiple points in the scene and organize them how you want. Me personally, I use this node in conjunction with the 3D objects. I usually don't create any points, but ideally geometry, but keep the points. So that's very useful. And last but not least is the scatter node. And if we quickly put a display flag to the end result, you'll see what it does. But let's go through the theory first. So what does scatter node do? Well, scatter node scatters new points randomly across a surface or through a volume. So when do we use this node? Well, you use the scatter node whenever you need to distribute points randomly or in a controlled way across a surface, volume, or along a curve. And these scattered points often serve as placement guides, for instance in geometry, particles, vegetation, debris, or pretty much any procedural pattern. And the way I got to this result is I created basically a shader ball. Then I dropped down this scatter node, which if I press P on my keyboard, which allows me to scatter points randomly on this surface. And I'm gonna put a reference flag to kind of view this in conjunction. And I'm gonna choose to adjust this slider. And this is basically how many points we want to scatter on this geometry. We can go from 1 point to 3 points to all the way how many your computer can handle. So that's what scatter node does. You can relax those points. You can all do all kinds of different things. So, and this is really cool because then we can add new nodes in the network to kind of build on this effect. And we learned about copied points now previously, right? So I can use these points to scatter my geometry onto this ball. See? Let me get rid of this reference here. See? I take these spheres, actually this sphere that I have scaled down. I'm using copied points node to scatter it on these newly created points here. See? And that's basically what the scatter node does. Okay, that's it for today. 10 nodes I use on a pretty much daily basis. Obviously, it's a big claim. Not always you use these nodes, but those are good starting points whenever you're learning about Houdini, you're trying to build up your kind of knowledge about these Houdini nodes. And I hope you liked it. I hope you learned something new today. And again, if you like, subscribe and comment with feedback or anything you like to comment. Those kind of things go a long way for me, because for me to keep doing this, it's good that I see some kind of response. And with that said, I'm going to see you in the next one. Thank you so much.